Hello friends, welcome to the today's video. So today we are going to discuss about another unsupervised method called decision tree. So this is a decision tree. It is another unsupervised method where it is going to learn based on the ensemble learning. So we are going to see what is ensemble learning. So here it is also an this is not an parametric classification. So this is which is going to happen in an unsupervised manner. Before starting the today's session, let me just give a summary of yesterday's bird eye view. So yesterday we have been seeing about K-means. It is another unsupervised method where there is no need of labels and there is no need of a human beings to make a classification. So here we have been just generated a scattered data first by using a make blobs. So creating circles with the cluster center. So once the cluster center have been just made, we are using a k-means inbuilt function which have been just available in an sklearn with an subsection of cluster. So we have been just changed this cluster centers to 4, 3 and just seen how the data is going to be just splitted by using a k-means dot predict. So this was based on the algorithms, like two steps was there. First one is like taking a cluster center mean, so random cluster centers, so later expand it. So this is a basic algorithm. So based on this steps, we have been just seen how to build a k-means from scratch. So we have been just defined a find clusters. So random value is going to be just generated by random cluster center have been just selected. So later it is going to be expanded for every iteration, so for every 3 steps. So first we are going to just find a clusters. Later we are going to see the same result what we have been just obtained by using a inbuilt command, that is k-means. So this is a user defined one. Later we have been just applied the same logic to the one real-time application like digit classifications, like what it is going to make a clustering. So here we are having 10 classes or 10 clusters, not classes actually, it is a clusters. So 0 to 9, that is total 10 in numbers. So later we have been just seen a confusion matrix. We have been just seen a tuning factor. So here we have been obtaining 79% of accuracy by using a tuning of Manford, converting a paper into another forms, that is 3D versions. So just folding a paper, we'll be getting many versions of it. So by using TSNE, we have been just randomized the components and we have been just had a clustering method and its accuracy have been raised to 92%. And this is a value of a unsupervised method where it can achieve 92% of accuracy. So this was all about the yesterday's session. So without wasting the time, let me just jump into the today's session. So a decision tree, what we have been said earlier, it is an ensemble learning. It is an example of ensemble learning. So the ensemble, the example of it is a very good example is a random forest. So let me just tell what is this ensemble learning, how the ensemble learning is going to just work with, and later we can just go for what is random forest. So random forest will be working on voting. So ensemble learning will be working on series of questions and it is going to give some answers after. So that is called decision tree. So the random forest is also same as a decision tree, but after giving an answer, the voting is going to happen. That is a one difference here. So let me just go in with a deeper version. So introduction, sorry, I have been use a shortcut here. Introduction to decision tree. So we have been just seeing the Nevis bias. It is a simple generative classifier that is based on the probability and based on some of our assumptions of probability statements, that is Bayes' theorem. We have been just made the Nevis bias have been made a respective classification. They were having many of a types, so that was based on a generative classifier. So SVM was another powerful discriminator which is going to provide you a yes or no based classification. So this is also an powerful classifier, discriminative classifier. So it can give yes or no questions, or it can answer for yes or no. So random forest is again a non-parametric algorithm. So it is based on the voting system. So it is an ensemble method. So let me just say what actually the voting is going to just do with it. So what is voting means? So you will be having some series of questions. Consider that. So what the series of questions we are going to just deal is, so this is, we are going to call it as a node. And next we are going to call it for branches. So after having each branch, you will be having each node. So you will be having nodes. So once the node is going to be present, you will be having a branches again like this. So this is like just like a series of questions which will be answering yes or no, yes or no, yes or no. At the end of a thing, you will be just counting how many yes are present and how many no are going to be present. So based on this voting system, the machine will just say that it has been belonging to that respective classes. So let me just give an example for differentiation between cancerous and non-cancerous cells. So here the data will be flowing inside the trees like this. So this is a tree structure, this is node, and these are all the branches. So wherever the data is going to be just flowing inside this tree, it will be continuously getting yes or no questions, and each learning or each node is going to provide its own decision. At the end, it is going to just, so all these nodes answer will be just voted, or it has been just collected. We are going to find how many yes are there and how many no are going to be present. So this is called as like voting system. So what is random forest? So it is also an example for ensemble learner built based on the decision tree. So based on the decision tree, the random forest have been just implemented. The only difference between the decision tree is and the random forest is the at the last, in random forest we are going to have a voting machine, but in decision tree yes no yes no. Once it reaches the end node, so whenever we are going to have a series of questions, but the last decision is, if it is yes, then the answer is yes. If it is saying no, then the answer will be no, like this. So that is the difference between random forest and decision tree. So decision tree is a very simple algorithm which can be designed by asking a series of questions. So I have been talking about the series of questions. So it is going to generate true and false. So example like if a customer, so if you are becoming a ML engineer in some of a company, and if a customer comes and asks for software to build a house prediction, so house rent prediction for some of a city. So in order to do this, you need to consult some of our experts. See like how exactly the traditional house rent prediction or house rent value fixation is going to happen. So the tradition values were like how many rooms, what is the square area it has been just covered with, or whether it has been provided a parking facility for transport vehicles, so that is parking facility, whether they are having any sorts of a grass area to spend some of time in an evening. So like this they are going to set a respective prices. So in order to study all those things, you need to consult one of our experts who is going to provide you how the house rent is going to be fixed. So after doing all those things, the respective cities existing house values need to be collected. You need to prepare a data set. So that is collect data set of a city. So as we have been just seen, I have just provided a Melbourne data set earlier while explaining pandas for you. So I am just having this feature. So consider we are having some 14 features like this. How many rooms, square feet, or what is the length of a house, whether we are having a transport facilities easier to that location, the address of a location, and what is the area of sitting, is it is having any gardens and all. So that is, if we are having 14 out of this, based on the customer's thing, you can choose some 4 to 5 features, efficient features. You can choose a model, train a model, and test and evaluate it. So this is called a simple thing what we have been just seen with. So the thing is like it is too much easier. See, let me take an example here. See, like you need to predict the, what is this? Value of a pencil. I'm just taking an as an example. So if you are a sketcher or drawing sketcher, so you'll be knowing that it will be having a different shapes or a different grades of a thickness of that pencil, lead 1A, 3A. If you are having any knowledge of a sketch, then it is going to just have a version. So one thing is like one broad classification. So here we'll be having a true false based questions. So binary splitting makes extremely efficient. Binary splitting means true and false. Let me take a first example, whether pencil is having an accessory of rubber with it. If it is yes, then the cost will be around 3 rupees. If it is no, then the cost will be of having 2 rupees. So this is a single type question. So if this is true, you will be having again some series of questions. So whether we are having a eraser for it or not. If else, some other questions like what is the thickness of a, so thickness of a pencil, whether it is 1A or not. If it is 1A, the cost will be present. If it is not a 1A, again you need to go on asking whether it is 2A, 3A, normal pencils, or a very thin pencils, something like this. In the here also, if it is no, again the same questions arise, whether the thickness. So yes, no questions. If it is yes, it will be giving some values. No, again there will be having some binary splitting of a data is going to happen. So each question will cut the number of operations or a number of approximations into a half. So whenever we are having like some degree of randomness, you need to just answer. What each question is going to cut down approximately half than its respective complication. So we will be moving towards the right answer for every question the machine is going to ask for itself. So the very tricky thing here is we need to decide, or a machine need to decide what amount of or a correct question need to be asked in each step while implementing any of a decision tree algorithm. The question generally divides So questions generally take the form of axis aligned, splits the data. So it is going to align with an axis and split the data into two groups. So each question is going to align the data and split into two groups, that is binary decisions. So using a cutoff value within it. So within the features. So the cutoff value is like some questions here. So like yes or no questions. So if it is not clear, let me take with an example of what I have been just speaking about, the house rent of one of a city called Melbourne. Why we are taking this one is we are already having data of it. So a simple question. So this is a sample decision tree. So does the house is going to have more than two bedroom? It is asking a very simple question. Yes, if it is having more than two bedroom, the cost is around 5,000. I am not just giving exact version, just I am just guessing. So if it is less than two bedroom, the cost is 3,000. So each question is going to align with the data and approximates the data into two different groups. So this is like the what we are going to just see with. So it is going to, so it is dividing into two categories. So based on the bedrooms, so the answer will be categorized into two things, and it is going to produce a predict the cost of a home. So this is a sample decision tree. So let us improve the decisions, like we will be having two scenarios here, how the decision tree is going to be improved. So I am just taking with the example where exactly the decision tree goes wrong here, how to overcome it. So the same question is like whether it is having more than two bedroom. The same scenario. One of our machine learning or decision tree have been just given the price as 5,000. And if it is no, then the cost is 3,000. Okay, it is 5,000, and if the decision is false, then it is 3,000. Some of our decision tree may just give a wronger results here. If it is S, it may give the answer as 3,000. If it is no, it may give the answer as 5,000. So this is where the machine is going to be just give some wrong decisions. We need to avoid it. So this is a one of a crucial decision where decision one is going to provide a good results. So here it is going to just fail here. Why? Because if it is more than two bedroom, the cost should be high, but here it is a vice versa. So now we need to add more number of features to avoid these number of errors. So more number of trees or more number of questions we need to add. So questions need to be added in order to avoid these kinds of scenarios. So adding more questions is like, so first basic question is more than two bedrooms. If it is less, I am going for, so lot size. What is the lot size? Whether it is more than 10,000 square feet. If it is S, we are just seeing that it is around 18,000. If it is less, we are seeing it around 15,000. So if a bedroom is of having less than it, so this is true condition, and this is a false condition. So this is false condition. So again, I am just checking the lot size here. So if the lot size is larger than 8,500, if it is S, we can predict the cost as 17,000. If this condition is false, we can give a decision saying that it is 13,000. So if we are adding more number of questions here, so these kinds of wrong things will be avoided. So we need to design more and more trees. So again, designing the questions is not up to the user. We can enhance the tree level and we can enhance the features. So that is like what is a data what we are going to just provide with. So let me just have a sample coding here. So the sample coding will be generating some of a data set for you. So we are going to have some two-dimensional data which is having a 4-class label. So it is going to be divided into 4 classes. So here we are going to design a simple decision tree built on a data based on the iterative approaches. So here iterative approaches means for every iteration it is going to divide the data into one or other axis. So it is going to divide into 2 groups or 2 criterias. Okay, we can just execute this so that the thing will be looks easier. So let me take a new scratch file here and I am naming this as rename this to decision tree. Okay, and I am taking a sample data creation here. So these are all the packages we are using. So I am just generating a random data here. So after random data, I am just having a plot of a tree, decision tree. Okay, here something like import NumPy. For plotting, we are using Matplotlib. And for scikits, so scikit-learn, we are using the same make blobs. Here the samples are 300, centers are 4. So I was been talking about we are having 4 clusters. For that we need to use a decision tree classifier and we are going to fit it. So here for every split, so for every after splitting, so there will be some upper part is going to be remain. So that is what this point is going to tell you. So node need to subdivide if all the colors are into the one branch. So whenever you are going to divide a data set, so into 2 groups like this in a vertical fashion if you are dividing. So there is no need to subdivide above this point. Why? Because these points are being categorized into 1 classes. So again you need to subdivide means in the next session. So after this respective point. So we are going to visualize the things. For visualizing purpose we are using this respective program called visualization. So we are going to see how exactly the classifier are going to just work. So this is we are going to fit it. We are just have one of a visualization of a classifier. It is going to take a model. So model means fitted model. Here the fitted model is in tree. X means data. So that is having a feature. Y means the labels. Whether it has been belonging to which class. So what it is doing? It is scattering the data. So later axis is going to be tightened version. We are just making a x limit, y limit. So x limit and y limit. We are fitting the model and we are creating a mesh grid. So this is an grid which is going to provide you a respective visualizations. So after this we are going to predict based on the trained model and we are going to give the classes here. And again we are going to set the axis limits here. So what is a maximum x-axis limit and y-axis limit. So we are just calling this visualize classifier. So once it has been called, we are going to just pass the decision tree classifier and x comma y. So after this, if needed, we can go for this. Okay, run this decision tree now. So we are going to just see the points, upper branches. So first splitting is going to happen. Let me explain this. So at the first execution, it may take time. Stop it and rerun it again. So the program is too much simple. We are taking a blobs, and we are just fitting using a decision tree. So decision tree classifier is available in sklearn.tree. This is what I have been just speaking about. We are having 4 clusters here. So this is, we are going to have a decision tree. Decisions classification based on the 4 values. So let me just take this here. So it will be easy for explaining with a pen. So going for a desktop, decision tree classified output. So as I told you earlier, we are having a 4 classes here. So for every time or at the first time of a split, upper branch remains same here. So this is a upper branch. It is going to be remaining same for the above points. There is no need to have a subdivisions here. So this is like how we are going to just make it. So there is no need to have a subdivisions here. There is no need to have a subdivisions except for nodes that contain all of having a only one color. So till that you can have a subdivision. So here you can just take a look here. So here at some point you can just see here. So there is a subdivision. So here this branch have been subdivided till all the nodes of that point is going to have a same color. So here also. So at some point the overfitting is also happening here. But here it is giving some of good results at this part, but here at this point we are having some of a overfitting. So that is what a visualization actually just mean with. Okay, we can just stop this. Okay, then we are moving further. Okay, let me take a pen again. I need to select this. I'm going further. So decision tree and overfitting. So taking 2 different conditions, and generally it undergoes a overfitting. So as I show you earlier, this region is where overfitted. So this is a region where the overfitting of a data is going to happen. So it has been smallly divided. You can just observe over there. So this is what decision tree and overfitting. So for both the trees, half the data is given. They work very well with some of a region, but in some regions it is going to be just failed. So to avoid a overfitting in decision tree, we are going for a feature called bagging. So in bagging, we are going to just have a, what is this? Random forest. So let me show this overfitting condition in a PyCharm. Okay, we can just go here, init, import helpers. We're going for a bagging method. So bagging is like, so we are going to have a multiple decisions. So it is based on the ensemble learning. So bagging is another method. So whenever it is going to make an ensemble learning, so whenever the overfitting of a data is going to happen, after this, it is going to find the average of a data. So it is going to find the average of a results. So once the average of a results is going to be found, so the overfitting is going to be just removed. So that is what here. So select the overfitting and average the results. To find the better classification, we are going to select the overfitting data, where exactly the data is going to be overfitted. So at this point, the data is going to be overfitted. At that point, we are going to make an average. So that the overfitting is going to be just removed. Ensemble on random tree structure is called as a random forest. So first thing, we are going for a bagging example. So it has been just available in a scikit-learn, so called as a baggage classifier. So here we are going to just see with a random forest. So as it has been told here, ensemble on the random tree structure is going to be called it as a random tree. Ensemble learning, you have been already seen, asking yes or no question on random tree structure. So node and branches is called as a random forest. So later we are going to have a voting system here. Okay, we are taking a bagging as an example. Going back to this. So again, we are having some bagging example here. So let me explain after having this. So I am taking a decision tree classifier in an sklearn tree and a bagging classifier with an ensemble, which have been present in sklearn. So decision tree classifier has been just molded or called in a tree. So bagging classifier, we are moving this tree. So tree is decision tree classifier, and we are having a estimators as 100 trees or 100 branches we are going to just do it. We are making a fitting of it. This bag is going to be pushed. So this bag along with the data x and y. So here we are going to see the respective output. Okay, if it is becoming too much late, you can just delete all those things. Okay, it has been came. So here we have been just seeing some of our overfitting. This is earlier data. Okay, after this we need to plot dot show, or else it will be just going off. Here we are going to randomize the data. So the data is going to be randomized by 80% of a training data is going to be just fitted or with a random subset. So this is a session what we are going to do with a bagging one. So in practical sessions like in a random forest, what we are going to do is in order to enhance the decision tree effectiveness, so we are going to inject the randomness based on the stochastic method. So that is going to be questions which is going to split into two choices. So this is a way what the data contributes. So data is going to contribute for making an effective decision. So or effective training method or fitting the effective data into the model. So based on this, we are going to find the randomness, desired randomness of a system. So this is like usage of a bagging. We are going to see what exactly the random forest which is going to be just doing with. So here, for example, tree of 80% of training data have been provided for fitting. So this is what the thing I've been just talking about. The effectiveness only when how splitting is going to be chosen. So this is going to provide effective results based on how splitting is going to be happening. So splitting is going to be based on the features, and machine takes this into a consideration. So based on the feature what good data we are going to provide, based on that the bagging is going to provide you a better results. So scikit-learn is going to do all these points automatically by using a random forest classification. So before regression, let me just go for a classification of random forest. So here we are having both classification and regression of a random forest. So we are taking a simple model here. So it is just a oscillation output. So how exactly the respective oscillations are going to be provided as a random forest value. Okay. sklearn, we are just importing ensemble and import random forest classifier. So after doing this, our thing is to generate a model. So using this random forest classifier, what we need to push model. Okay, we can just say what is how many estimators we need. So for this decision tree, what we have been just done is 100 estimations. The same thing has been implemented using random forest, but there will be some change in a random forest. So the random state will be 0. So for every time the same points is going to be just generated. So we are using visualization classifier and we are pushing model and data x comma y. So after this we are telling that stop it. So let me just give a title as well here. So the title can be like random forest. Okay, we can go for an execution. So this is a random forest. All the 100 estimation is going to be just made with the averaging result. So the overfitting have been just removed here. So you can just see there is no overfitting of a data. Overfitting means actual data following. So that have been just removed here. So this is a usage of a random forest. So here we are having an example for random regression. So random regression is like we are just taking some of our created oscillations. We are just taken simple model using a random regression model. We are just going for a oscillation, fast and slow oscillation changes. We are going to just see with the random regression. So this is what the oscillations, fast oscillations and slow oscillations, what we are going to just see with. We have just taken a plots and so after plotting, let me wait let me just wait till, or let the machine just wait till I am going to press the close button. So here we are just taking a random values here. So let me just show you just a random values range and defining one of a model, taking a x value as an input. Fast oscillation is 5 into x. So slow oscillation means for every value it is taking too much of, for every change in a degree of pointing with the next value, consider this as a first point. In order to plot the second point, if it is a slow oscillator, you are going to add first point plus 0.5. If it is fast oscillation, previous point plus 5. So fast means it is going to have a nested results in a difference of more values. If it is 1, the next value is 6, 11, like this. If it is fast oscillation, if it is a slow oscillation, 1 means 1.5, 2, 2.5, you will be getting more points. So this is what the model is going to just do with. So we can just stop and rerun it. So we can just see the oscillation output, how it is going to just vary with fast oscillations and slow oscillations. So here is a thing what you are going to just see with the oscillations. So here you are going to see some of smoother curves. We need to plot the random forest curves as well here. So that was the plot which have been provided for slow and fast. We need to have a prediction of random forest values here. So xfit yeah, this is what the thing we need to just do with. So this is like slow oscillations and fast oscillations which are being generated. For this we need to plot a respective, what is this, random forest. So this is just an oscillation generation. We need to plot a random forest for this, and we are going to see how this random forest is going to guess the respective output. So first we are going to see the data, how the slow occurrence is going to happen, slow oscillations and a fast oscillations. For slow and fast oscillation, how random forest is going to make a prediction. So this is, you can just see the red color is a random forest prediction. So this is a data, and this random forest is predicting the next oscillation. So it is almost accurate. So this is, by this example we can come into picture that random forest can just predict the multiple values. So here multiple changing values can be predicted. So some of the values will be missed, and that will be considered as a false prediction. But random forest have been just considerably made this predictions for a multiple data as well. So next we are having one of our example, a real-time example, that is digit classification, what we have been just seen in an K-means, but that is another version, but this random forest is another version. So let me just explain this, what is this digital classification. As we are knowing that this is a voting machine. So based on which image we are giving, so you consider we are giving one of our image that will be running in the branches like this, and in out of 10 groups it is going to generate some of our votings, and this image will be having one of our voting system maximum here. And if this is 3, and if you are having a maximum voting to the 3, it may say it as the given number is 3. But if the given image is 8, it will be resembling here. So sometime it may tell it as 3, and sometime it may tell it as a 8. So that is based on machine's feature values, how it is going to just do with. We can just go for this. I'm just deleting all this. Okay, we're just taking another scratch file here, and I'm just naming it as a decision tree, digit classification using random forest. So I'm just copying and pasting this. So here we are having sklearn import load digits. So this is a data set which have been available in sklearn. So digits 0 to 9 will be available. So we are having keys, what are the respective values. Oh, we not imported this matplotlib. Okay, matplotlib need to be imported. Later, what is error? Random forest classifier. Okay, random forest classifier is available in sklearn Ensemble. Then what is the other error? Okay, sklearn, you are going to change it to model classification. Train test split was earlier available in cross validation. Now it has been moved to model selection. So random forest classifier is not gone again. Oh, regression, not regression. I need a classifier here. random forest classifier. Okay, all the things have been just gone over. SNS, we need SNS, that is Seaborn, and it has been set as default. Okay, all the errors have been just removed. So we are taking some of a data set. So we are just displaying 6 images here, and we are going to subplot it. Left, right, bottom, and all. We are going to have this plotting. So based on this, we are just showing the digital images. So we are plotting 8 images, 8 cross 8. So it is going to run for 64 times, and we are going to display it and label the image with a target value. If you are giving 0, we are telling that it is a labeled value as 0. So we are just pushing some text here. So model selection, we are going to split our data set into train test, train test. So X test, Y test, Y train and Y test. We are going to split the data and the targets. So data will be available from 0 to 9. Target is like it is going to tell whether the data is belonging to which label. If you are going to say the features of 0, the target is saying that it is 0 value. So we are having 1000 the estimators. You can change this 1000 to 500, 900 or 10,000, 5,000. So after some predefined value, the results will become same. See, if you are increasing this to 1000 to 2000, some slight changes will be there, like 2 to 3%. If you are changing to 1000 to 10,000 or from 5,000 to 10,000, there will be very much changes, like 0.001. So we can just see this, what are all the things we are going to just so plot dot show. After having all the things, we need to just have this plot dot show. Any other things? Okay, here. Okay, we can just have a digital digits classifications which have been just running here. So the first figure, okay, it may take some time to execute. So it is going to display some of our figures, data set figures. So here you can just see 0 to 9 and what is the precision and what is the score and what is the support for that respective, how much values it has been just stirred for 1000 classes. So here the accuracy F1 score means it is a type 1 error, type 2 error, what you have been just seen that in the previous video, like what is type 1 error, what is overfitting and all. So the accuracy here is like 98% for a 450 samples. So weighted average accuracy. So this is the thing what we are going to just see with. So this is what I have been just talking about. This is our images and label class, the text what we have been pushed. And here we are having a confusion matrix which have been just gone here. Okay. So the confusion matrix will be knowing at the x-axis will be having a, what is this, the true labels. In the y-axis will be having a predicted labels. Okay. Let me just show you the confusion matrix so that it will be clear that how the efficiency is going to happen. So if it is not just printing over there, you can just go to the console and you can just see what will be the output here. So this is what the confusion matrix which have been just generated here. So this is what the confusion matrix, true labels versus predicted labels. So 0 has been correctly predicted, 37, 1. So here it is having a confusion between 2 and 3. One misclassification have been happened. But whereas in 3 it has been, this is what I was been talking about. At one time it may just give it as a wrong results. 3 has a 8. In the 4 it may wrongly detect as a 7. 5 has been wrongly detected as 9 in some of the scenarios. In the same manner you can just see for 8 and 9 also. So 8 may wrongly detect as 3 and 1 as well in some of our scenarios. Whereas in 9 it may detect as a 5. So this was all about how to make a classification of our digital values. So 0 to 9, if you are training it, you can just detect any number of images using what is this, a random forest, and it has been just provided good results as compared to the other things. Okay, so later, so that's it for this video, guys. I hope the information is what we have been just discussed is informative for you. Let us meet you in the next video. It is okay. Thank you for watching this video.